Good evening friends. In this segment I am going to explain you the basics of electric potential and potential difference. So first of all I want to just give you the meaning of and what is the significance of electric potential. So here I am just considering a positive charge which is placed in a space. Let's suppose this is the positive charge and somewhat I am just considering its particular range. Okay. Let's suppose this is a range of this particular charge plus q, and outside the range of this particular charge I am considering a test charge. Let's suppose the unit test charge I am considering plus q naught, which magnitude is unit, and it is just placed for our consideration purpose. We can take this particular charge in the infinity also. So we have to understand that what is the meaning of electric potential. Electric potential is a total work done by the external agency, to place a unit positive test charge from infinity to a particular point inside the field. The total amount of the work done by the external agency to place a particular charge from infinity to a particular point inside the field is called electric potential. Means if I want to just, let's suppose this is somewhat infinity place, and from this particular point to a point inside the field, if I am just placing this particular charge here, so whatever the work done we have to done in this particular process, that is called electric potential. Here our basic formula of the electric potential is V is equals to W upon Q naught. V is equals to W upon Q naught, where Q naught is the test charge, and I can just consider it a unit magnitude. So means the total amount of the work done by the external agency to place a particular test charge from infinity to particular point in the space is called electric potential. Now what is the important thing? What is the important thing here? For describing the electric potential, the force has to be applied on this particular test charge. So that force must be equal in the magnitude of the force which is applied by the field of this particular charge at this particular point. Let's suppose the distance between these 2 points is what? R. To place a particular distance we have to apply some force also. So that force must be equal to the electrostatic force between these two charges. And the important consideration is during this particular work done there must not any acceleration act on test charge. Means that there will not any resultant force will be acting on this particular test charge. Whatever the force we are just applying in an opposite direction of the field, here that particular work done must not be done by the field. It is done by the somewhat external agency. So that particular force whatever we are applying from the external source, that must be equals to the electrostatic force between these two charges, and the resultant should be 0. There will not any acceleration act on the body. For determining the potential at a particular point, this is the important consideration, that there should not be any acceleration acting on that particular body which has to be placed inside the electric field. Okay, so that should be minimum force. What is the important thing? The minimum force must be applied on this particular test charge to place a particular point inside the field, so that that particular force which we are applying from the external source must be equals to just only the electrostatic force between these two charges. So that was the important consideration, and I hope that you have just noticed this particular point. This is the important criteria. Okay. If I want to just calculate the unit, so V is equals to W upon Q, The unit of work done is joule and the unit of charge is what? It is coulomb. So joule per coulomb, the electric potential unit is what? Joule per coulomb, and 1 volt is equals to 1 joule upon 1 coulomb. So again its unit we can say volt also. So its SI unit is joule per coulomb, as well as we can use it volt also. Okay, so this was our electric potential, that the total amount of the work done by the external source to place a particular charge from outside the field to inside the field at any particular point. So that work done is called electric potential, and that work done must be against the or in the opposite direction of the work done by the field. Let's suppose here in this particular case, this charge will repel this particular charge, but if we want to just place this particular charge in this particular point, so we have to apply somewhat force in opposite direction so that it can be remain in this particular point. So that is the important point. That's why I just told that that particular force which we are applying from the external source, that must be equals to the force which is applied by the field on that particular point. Okay. Now one more thing is there, that what is the meaning of potential difference. So these are the very basic term. Okay, let's suppose I am considering 2 points, point A and point B, okay, which are inside the field, So I have considered 2 points inside the field, A and B. So if inside the field, if I want to just move any test charge from one point to another point against the direction of electric field or against the direction of the electric force, means here at particular point A the field is intense, and at the particular point, because A point is nearer than point B, so at this particular point the intensity will be greater, and this particular point B intensity will be lesser. So if I want to place this particular plus q charge from point B to A, which is in the against direction of this field, because the field is direction is what? It will be from A to B. Okay, the direction of field is from A to B, but we have to just move the charge in a opposite direction of the field. So inside the field, if the test charge is being displaced from one point to another point in a against direction of the electric field or the external electric field or the field due to this source charge, so whatever the work done has to be done, that work done is called electric potential difference, because both the points are situated inside the field. So that's why we get the potential in the term of their difference. So here the potential difference between these 2 points, between A and B, so VA minus VB is equals to W upon Q naught. This is the formula of our electric potential. Means, let's suppose if I am considering it 1, so the total amount of the work done to be done by the external agency to place a unit test charge from one point to another point inside the field in a opposite direction of the electric field is called electric potential difference. Okay. In electric potential difference, the unit is also just like same, joule per coulomb, or you can say volt. Okay. Here the main important thing or the main consideration thing is that whatever the force we have to apply to make this particle move from this particular point to this particular point, so that force must be equal in magnitude of the force applied by the field, but the direction will be opposite. This is the very important, means there not should be any accelerating force act on the body. for determining the potential and the potential difference, there must not be work done, or the force which is applied by the external agency, that should not be accelerating force, that must be just equal in a magnitude due to the force applied by the field at that particular point. So this is the important consideration only, and we have to remember that this force is a least force. It is a minimum acting force on the body to displace from one point to another point, which will just counterbalance the effect of the external electric field. So I hope that this is somewhat helpful for you, and it was just introduction of electric potential and electric potential difference. In the next video, in the next segment, we will see the different cases of potential due to charge, due to dipole, and quad pole also. So stay tuned to our channel. Thank you.